Hey guys, Jason again. I'm gonna finish out assignment 2 here. So we're gonna plot it and then we'll do a t-test. So let me share my screen here. Go to R and I'll get rid of some of this so we can do it together. Okay, so we already did all of our formatting. We are gonna graph our experiments separately, so experiment 1 versus experiment 2, etc. So we're going to need to filter our data like we did in assignment 1 using the filter command. So we're going to create snail data means standard deviation experiment 1 using the filter command, right? So we're going to filter our snail data means standard deviation data by only having experiment equal to 1, right? So remember, you use double equal signs and we want them to be equal to 1. All right, let's see if that worked. Experiment 1, let's see. So we've got our mean, our standard deviation, which we wanted still. And then, yep, looks like it limited the data just to being experiment 1. So it's easy to check that, right? So it looks like we're on the right path. So I guess I probably will write a note that says limit the, or filter the data by experiment, just so I know what this command does. Okay. Next, we're going to start a graph. So we're going to start going towards this bottom right-hand corner plot. So let's see if we can start getting there. So we're going to need to use ggplot2. So you're going to need to use your library ggplot2 command, right? Cool. I'm having an issue with some vector sizes in another assignment, so I'm just gonna delete this, but or it doesn't really matter. I'll just keep it. So library ggplot2. So that's what we're gonna use. We're gonna use the ggplot command, same command that we used to make our box plots, right? So we're going to here. I'm just gonna delete this command because it's causing me some problems. Or I'm just gonna sell like that. ggplot snail data means standard deviation experiment 1. So we're gonna plot that. We're gonna say what our x and y are gonna be. Oh, it's totally different than that. Interesting. I don't know why it's doing that, but it has to do with another project. So it won't happen to you. Don't worry about it. So we're gonna say our x is generation and y equals mean, right? And then we're gonna say the color is our snail color. And then we're gonna add in points. We want geometric points. Sorry about that. Geometric points. So that should work. So let's see if that works. Could not find function GG double P plot. That's because I spelled it wrong. Sorry about that. Could not find function geometric points. Let's see. I think it might just be, I said geometric points, but it should just be geometric point. Singular. Sorry about that. All right, so then that worked. So it should spit out in our plots our points. Perfect. So we have our generation, our mean, our snail color. We kind of know what the trend's doing, so that's good. All right. Now we're going to add on to this, right? We're going to add on a line. So you just type plus geometric line. line, and that should add a line to our plot. Let's run that, make sure that works. Yep, added a line, which is good. Now it's clear to see. Now we want to add labels and change our axis titles. So we're going to use our scale Y and scale X continuous commands. So we're going to say scale X continuous, us. We're going to name it name equals generation, right? Because it looks a little better with capitalization than how it looks now with the undercase. So, oh, I forgot the plus. That will make it so that it will not add. So we need to make sure that every time we add a plus, we're going to add our scale Y continuous. Gosh. Continuous. Sorry about that. We're going to name it mean, right? Maybe we'll capitalize mean, so we liked how that looked. And then we're also going to change the scale a little bit. So R had decided for us that it should be from 0 to 50, right? Or 0 to 40, right? It looks like it's the highest 40. But when we add in our error bars, we might not be able to see the full error bar. So let's just get ahead of this issue and change our axes to go from 0 to 50 instead of 0 to 40. So we do that in our Y continuous command. And we put in this limits equals C 0 to 50. All right. Let's do that. And then let's see where we are from there. All right. Let's see if this ran. Yeah, that seems to have worked. Perfect. Sweet. So now we can add in a label to our legend over here. See how it's lowercase? Maybe we want it to be uppercase in 2 different words. So we will use the labels or labs command. Labs color equals snail color. All right. So let's see if that worked. Run. Yeah, so now we have it capitalized and 2 separate words, which I like better. All right. Now let's add in our error bars. So now we're going to say plus geometric error bars, which geometric error bar aesthetic. Gosh, I'm sorry about this. Aesthetic Y min equals mean plus standard deviation. And then Y max is going to be mean minus standard deviation. All right, let's see if that worked. Adding in the error bars. Oh, perfect. Absolutely perfect. So it looks exactly how we want it to. Has the 2 lines, has the error bars. Perfect. So now we're going to do the same thing. So we'll say step 4 is graph experiment 2. So we do the exact same thing, but we instead of filtering our data by experiment 1, we filter it by experiment 2, and then we do everything the exact same. Okay, so I guess I could do it for you quickly, but it's pretty simple, right? So we just do filter snail, maybe we'll recall it experiment 2, filter have it be 2. So that creates our data set, right? Run. And then we'll use this ggplot command, but we'll use experiment dataset 2. And that should create experiment 2's data. Does that make sense? Yep, cool. So we can tell that these in experiment 2, snail color doesn't matter as much versus plot 1, where it looks like snail color really had a big difference on the fitness of the snail. Right? Okay. Cool. So now we graphed experiment 2. Now we're going to do a t-test, which is relatively easy actually. We're going to create data sets, create separate data sets based on color and generation, right? Because that's what we want to know the difference, right? So we're going to say we want to know within a generation how the colors are different, right? Cool. So we're going to create those different data sets. So we'll create red one is filter snail data, because we want the raw data, because in the t-test it requires all the data to use. So we don't want to just use the means. Okay. Experiment equals 1 and generation equals 3. And obviously snail color is going to be red because we named it red 1 equals red. Boom. Alrighty, let's see if this creates what we want it to. Oh, so as you can see, I forgot to create anything. I just filtered it. So that means that it just pops out in our console. But to be able to use it, we want to create something. So we're going to create red 1, and that's going to be this filter. Okay, so I created this red 1. Perfect. So now we just have red snails. Okay, we're going to do the same thing for white. So I'll just copy and paste, honestly, call it white 1. And we'll go to the end of the command and change this to white. Now we just have experiment 1, generation 3, white snails. Okay. Now we're going to do the same thing for generation 2, or experiment 2. Excuse me. Holy cow. Okay. So we're going to copy, paste for experiment 2, red 2. Boom. And we're going to do the same thing for white 2. White 2, experiment 2. Okay. So we got to create white 2. And now we're ready for what step are we on? Step 4. Step 4 is going to be run t-tests. Cool. All right. So the t-test is a pretty simple code. It's t-test. And so we're going to run red 1, whoops, red 1 snails, right? The number of snails, and compare it to white 1 snails and compare their fitness, right? All right, let's run that. And then we're going to get our output in the console, and we're going to be looking at our p-value, right? So if our p-value is above 0.05, we'll reject our null, and if it's lower than 0.05, we'll fail to reject our null. Right, okay. So we're going to do the same thing for 2. And then we will use these numbers to write our handout. So this one, we failed to reject our null, right? So this is over 0.05. And then the other one, this is under 0.05. So we reject our null that they're the same, right? Okay. Here we fail because it's above 0.05. Here we reject our null because it's below 0.05. Alrighty. Okay, guys. If you have any questions, let us know. And that's the end of assignment 2 video. All right.